Hey, everybody, and welcome to the Ignited Podcast, Striking Industrial Automation Conversations. We're your hosts. I'm Travis Cox.
And I'm Thomas Burke.
And today we have a great episode for you called Data in Motion, MQTT Sparkplug B, and why the edge changes everything.
Our guests today are two people who really don't need an introduction. They are Arlen Nipper, who's the president of CirrusLink Solutions, a strategic partner of inductive automation, and Benson Houghland, who's the VP of Product Strategy at Opto 22 and a premier inductive automation technology provider.
And I have to say, guys, this one is exciting for me, right? Tom, with you joining inductive automation and me being able to work with Arlen and Benson over the years, I've got the three titans of industry right here. And it's all the amazing things that have happened have been from a lot of work that you guys have all done. So I got to say, it's a special one for me today.
It's really a pleasure, and it's a great opportunity. And I've known Arlen and Benson a long time, and we've worked together for a long time, way back when I first started OPC. So
now
rock and roll.
I know, that you guys don't need introduction, but first, for the audience, for the people that may not know who you guys are, why don't you guys introduce yourselves? So why don't you start, Arlen?
Well, hello, everybody. Well, first of all, really excited to be on the Ignited podcast, and I think this will be a lot of fun. So, Arlen Nipper, I am the president of CirrusLink. I've been doing industrial automation for 48 years. I just won a Lifetime Achievement Award at Prove It. So I guess I've got to start over now, and we'll do the next 48 years and see what happens. But got started as a SCADA engineer for Coke Oil. That's where I learned the basics. I learned what a 4 to 20 milliamp transmitter was. And I learned what limit switch, on a motor operated valve, and what a PID control algorithm is, and what a PLC was. So that was great. And then from there, I went into some businesses where I was the CTO for embedded computer boards. Finally, fortunately for me, not for Benson, but I jumped out of hardware about 12 years ago when we started CirrusLink, and really started CirrusLink to basically bring MQTT back to OT. Andy and I had invented MQTT for Phillips 66 on a mission critical midstream pipeline control system. And that was in 1999. And then jump forward to, 2012, 2013. And it just kind of pissed me off that Amazon had MQTT and Google had MQTT and Azure had MQTT, but we weren't using it that much in automation. And, what a difference 10 years have made once we got MQTT technology on the Ignition platform.
Absolutely. And then over to you, Benson.
Yeah, so first, thanks, guys. So excited to be here with you on the Ignited podcast. And I love the topic that we're going to discuss today. But my name's Benson with Opto 22. Been here about 31 years here at Opto. And prior to that I had a couple of IT-related businesses. And that part of is the, my narrative or my history with Opto is, coming in with some IT background, and the combination of IT and OT in a single system has kind of driven the product design. And for me, that's part of my role here is product strategy, and also I dabble in the marketing side as well. But super excited about joining you guys. And to Arlen's point, he got out of hardware some 12 years ago, so I'm looking to fill that gap. We've been doing this for 50 years at Opto, so we've got quite a track record as well. But some of the new stuff that we're working with, we've been partnering closely with Inductive now for over 10 years.
Yeah.
Well, some of the first hardware that had Ignition Edge embedded on it was of course, one of our Groove boxes. So it's fun to be where we are today and seeing the progression, and super excited about the progression moving forward.
We're really excited about having you guys here. And, one of the fundamental questions, and Arlen and Benson, you both can answer. I mean, given my background in standards and, commitment to standards and how excited I am about both, Inductive and Opto 22 being so committed to open standards. But can you kind of, just give me an overview for our audience of why MQTT and Sparkplug, and what problems do they solve?
the quote, the invention of MQTT was the fact that nobody came to Andy and I and said, hey, we need you to design a new product that can be used in automation. We literally both kind of came in and we were working on a project for Phillips 66, and we were just trying to make it work better. And that was, they had limited bandwidth over a TCP/IP based VSAT system, and they were still polling, right? They were still literally sending polls. It took them 15 minutes to get around 400 booster stations. It took them 2 minutes. If they sent a valve open command, they would start a stopwatch, and if it didn't go in transit in 2 minutes, they were supposed to call somebody. I mean, think of the stress if you were an operator. But it was around, this is 1999, they were paying around $4 or $5 million a year for communications bandwidth over a satellite system, a LEO satellite. So, or sorry, GEO. So we started thinking about it, and the backstory is it was kind of the genesis was that the SCADA manager, Steve Koenig, were really good friends with the IT manager, which that was unique, right? IT versus OT. But the IT manager said, hey, we use MQ series. And it's really cool, Steve, because we can decouple our IT applications. So one application can publish information, another application can subscribe to that. And we're not ripping up our IT applications and rewriting everything when we want to create another piece of information. So Steve thought about this, and he's called me into a meeting. He said, Arlen, can we publish data from our booster stations? And I go, well, I don't know. I mean, let's look into it. So Andy was a great help. Andy came from IT. I'd already been in OT for 25 years, and we really hit it off. And I said, okay, Andy, this is what we have to do on the operation side. And he said, well, this is how IBM MQ works. And we took the original MQ series header, which was like 5,000 bytes, and we kept smashing it and smashing it down. And the kind of our motivation was every byte that we could take off the wire was another $50,000 in savings a year to Phillips 66. So Andy would come in, hey, I was in the shower this morning. I just figured out how to save another $100,000. And it just kind of worked. And we got to the point where the last piece that we had to have for this to really work, to do report by exception, is we had to have state management. Because if I have 400 booster stations and they're all there, and just trust me, they're going to tell me when something changes. Well, you can't do that, right? You got to have state. And that's when we came up with the last will and testament, i.e., the fact that if you're a remote coming in, you register your last will and testament. If you die, if you fall off the IP network, and satellite, it was rain fade, then you were last will and testament. And then we would go back to the SCADA system, tell all the operators that, hey, these guys are off, data stale, it's offline, last known good. Now, when we got done with that project, we went from literally from 15 minutes to about 10 seconds for updates. For command and control, they would send a valve open command, and before they got their finger off of the execute button, the valve was going in transit. So it was really an order of it was a tectonic shift
Mhm.
in the way that you do SCADA. But nobody, I mean, you can imagine 1999, this was completely off, unique. And it took another 15 years for it to even kind of start to take off. And I'll get into the other, looking back, I didn't notice that I didn't say anything about cloud. I didn't say anything about security. I didn't say anything about AI.
So much innovation has happened, and you said this a few times, Arlen, that the great thing about MQTT is you could publish anything on any topic. And the bad part about MQTT is you could publish anything on any topic. And so in order, like Benson, from your side, right, for hardware and for software to work in harmony, like we had to have something, right? And enter Sparkplug. How has that really changed things?
Yeah, and I think that's, and I'm going to get to Thomas's first question about open systems, because it has to be done that way. I mean, if we look back in history, back in 1995, early 96, Thomas and Opto and a handful of other companies that don't exist anymore actually got around a table with Microsoft and came up with something we called OLE for process control, which then turned, of course, into OPC. And the reason for that was this notion of being able to get data from operational equipment. Back then, it was into a Windows environment. But the key was it was open. And then fast forward, a few years later, Arlen and I meet at a conference. It was back then, it was called M2M. And Arlen had his MQTT protocol. And first thing that was most important to me was, well, is it open? And Arlen did all the heavy lifting. Him and Andy Stanford Clark moved that out of the IBM ecosystem into the open source. So it's super crucial, at least in my mind, that we're working with these technologies that are indeed open. But the challenge with MQTT is just as you described: publish anything on any topic. We had to solve that problem. So when Arlen and I were first talking about MQTT, and I wanted to embed it in our products because it was open, that was a fundamental challenge, is how do we set up a system that takes advantage of publish subscribe, but at the same time provides some degree of data, payload, formatting, namespace, organizing this data in a way that other systems know what the other systems are talking about. MQTT is great, but unless you're way ahead of the curve and know exactly all the topic namespaces for all the different people that might want to get that data, that poses a pretty big challenge. And that's when Arlen and I saw each other again in Chicago, and he said, "Benson, I've got this new technology. It's basically an add-on to MQTT, which was Sparkplug." And then he coupled that with, I'm working with this company, Inductive Automation, who frankly I didn't know a lot about back in, was this 2015 or so.
Yeah.
And that's when all the pieces came together. Now we have MQTT, we have Sparkplug that puts some definition around that data, state management, store and forward, secure connections, all of those things. That's where it came together. But at the end of the day, it's open. And more importantly than all of that, is that it does solve real-world customer problems. And our website's littered with case studies of various applications that we've done where it really truly solved a customer problem. And Arlen talked about Phillips 66 in 1999. It's 2026 now, and we just published a case study of yet another application somewhat similar, but the enormous amount of bandwidth they saved and dollars they saved across 180 systems that were for a large water wastewater application up in Genesee County in Michigan. So what Arlen solved way back then are still the same kind of problems we're solving today, but now we're taking that to another level.
Yeah, I think Arlen, the industry owes you, right? Like you, that's why you got the Lifetime Achievement Award of just not only coming up with MQTT, but really understanding the need for this industry to have a format that we could easily share data, be plug and play. I mean, this is the thing that's actually pretty incredible to see today, right? It's I still feel like a kid in a candy store when you literally plug a device in and it's automatically shows up in ignition on a dashboard and the data is ready to go and even contextualized. It's like, wow, like this is just magic. Even though we know it's not magic, but it feels like magic.
We've been doing this with Inductive now for 10 years. And still today, you can have that conversation. They go, yeah, but you really can't use, and so you explain Sparkplug, and at some point there's that eureka moment. Still with a lot of customers, they go, oh, I get it. Okay, now I'm good. And now, their biggest advocate is Sparkplug. But that, and realize Sparkplug didn't just fall off the turnip truck. So if you look at what John Lujan and I did, so Andy and I got done with MQTT, but John Lujan and I had to make it work for SCADA, right? So we had to write a driver for Oasis Omnicom to listen to MQTT publishes coming in. And so at the time, we modeled it on top of Modbus. So we would go out, do all of our polling out with our edge device, Allen Bradley PLCs, flow computers, things like that. Bring that in, model them in Modbus, then get the Modbus registers report by exception. Our birth was literally all the Modbus registers we had to find, and we brought those in. And it's ironic, we had a UNS in 1999.
Yeah.
It was Pipeline 1, Booster Station 1. So Phillips 66, Pipeline 1, Booster Station 1, PLC 1, and then the Modbus registers for that. So we had a working notion, and this had been running for 15 years, quite nicely, by the way. So, but I realized that we weren't going to be able to take a pretty cryptic binary payload and make that work in today's world.
Yeah.
So that's where I kind of took lessons learned from all that work that we had done over those 15 years, what worked, what didn't work, what I wish I would have thought of before I put all this together, because John and I we got in a dead end because we didn't put that Sparkplug B in the front, right? So now we were stuck. We couldn't do the next version without updating everything. So that's where the original kind of spark for me sitting down over a weekend and writing the Sparkplug spec, but actually the discipline that Wes and the guys have taken to turn the spec from a document to a proper specification to a proper implementation with all of the TCK testing going behind it. And now, like you said, Travis, if we're just looking for a tag, even a simple tag without a UDT, we don't get just a tag or just a register. We get the name, we get the value, we get the timestamp, we get the engineering units, we get dampening, we get anything else you want to decorate that measurement with. That all comes inclusive, and you get that automatically.
Yeah.
And we tried to kind of even the keel. It's not binary, but it's not JSON,
Yeah.
right? So we kind of went into the middle with using Google Protobuf, and I think we made kind of a good trade-off there as far as what we can do and what we can represent very, very quickly. And then when Ignition started doing UDTs, Wes Johnson came up with the hey, let's do a Sparkplug template. And now all of a sudden, now we're really going, because now we can publish models over Sparkplug B now as well. So for me, I'm like you, Travis. It's like, this is cool. I can go over here in 3 minutes. I can build a UDT, put it into a hierarchy, build the hierarchy to look like a proper UNS with ISA 95 format, and hit a button, and boom, it's in my Ignition gateway.
It's also important to understand and to know that Sparkplug was built, the MQTT and Sparkplug, was built for specific use cases, right? And that was, to get data from the edge into these centralized systems, to be a pub sub format, to publish it by exception, and to save on bandwidth. We still had telemetry networks, that are out there, or sites that are on slow systems, and you have to be able to publish that efficiently. So all decisions of Sparkplug were made to solve that pain point.
Right, but even now, I mean, look at the the nervous system of a data center and how they're really leveraging Sparkplug in laying that down to where the data centers are dynamic. They grow, they add this part, they add this part, and by using MQTT Sparkplug, these data centers are able to basically go with the flow as they go in. They always have that single source of truth of data.
So, we've got all this great technology now, and we know it's being deployed in a lot of different ways. So, what are your thoughts on this whole concept and the role of the edge? And what is the edge doing, right, in terms of, being into this new architecture and fitting together to solve these more complex problems where, there's 23 million tags out there. How does the edge fit into the equation?
Part of that comes down to, how can we take available compute power and memory and so on and push it down as close to where the original source of data is? And that's really what edge computing is about. And that's the world that we live in. Now that means generally some piece of hardware that's running, some level of software that's going to make that last mile or last inch connectivity down to instrumentation, down to PLCs and so on, pull that data in and then start to democratize that data up to upper level systems. Arlen was talking about data centers. We talked about oil and gas, and frankly, that's the beauty of MQTT and Sparkplug. We have another application that's with a tier 1 automotive supplier, and in this case, they had over 100 injection molding machines. Now, you could have taken the traditional approach, put something in that scans all those, poll response to all those machines to pull the data in so we understand what's going on. But instead, they looked at the architecture and said, no, what makes sense is putting an edge device in that knows how to make that connection and then publish that data back to infrastructure. In this case, it was Ignition. And now they have all these systems out there that are publishing their data back in rather than the other way around. And so when people think about MQTT and Sparkplug, they're thinking oil and gas, water, wastewater. Those are classic use cases. Now with data centers, now in manufacturing, that same architecture rings true because, again, we're getting the data from the edge. More importantly, we're publishing that data on change. And finally, we're able to secure those systems as well. By putting secure edge devices down there in case somebody gets on the network or whatever, you don't want them hitting those machines. This is a way, again, of protecting those systems because we're using the publish subscribe model. We're absolutely, eliminating for the most part the attack surface that, say, somebody did get on the network that they could do some damage. So more on cybersecurity later, but I wanted to lay that out there.
It's important to note that we've got two people here that have had a deep, rich background with OPC. We've been talking about MQTT and Sparkplug, and I think there's a lot of people out there who truly kind of get confused or think it's OPC versus MQTT. And Tom, I think it was a few years ago at ICC where we brought you out, and you and Arlen did a presentation together. But we all know that's not a versus, right? There is a stack that we're looking at there. Can you guys comment to that and what you guys are seeing out there?
Yeah, you bet. OPC has been around for over 30 years now, in various forms, of course. And it was invented at the time to solve a problem at the time, and that it still solves those problems today. The beauty of OPC is not only the connectivity but the data modeling and so on. And for that reason, we continue to support OPC. Actually, OPC servers right on that edge hardware for those given use cases. But truly, they're complementary. And by that I mean there are going to be times when you're working with a device that maybe need a native device driver to it, or it happens to use OPC, but you're going to need to take that data, model and contextualize it properly, and then get it up to a UNS. And this is where they become complementary. In fact, many of our applications use the two technologies together to solve problems. And I think that's again, you brought it up that people have this MQTT versus OPC going on in their minds, but it's not that at all. They work beautifully together.
So Benson, I couldn't have said it better. I really appreciate that because it's exactly what Arlen and I have been talking about a long time. They're complementary technologies. They both have a place in our industry to do certain things, and they do certain things well. And I'm very happy to be associated with Sparkplug now. And I'm going to be doing a lot of areas of, creative things to help evangelize the Sparkplug technology because I'm a strong proponent of open standards and specifically the great work of Sparkplug.
You mentioned something really important, Benson, which is when you look at standards that are out there, obviously adoption is important, but it's all about being able to solve different problems, right? And not one standard is ever going to solve every problem that's there. But the MQTT and Sparkplug really, it solves tremendous amount of problems when talking about especially scaling systems and getting data from remote assets and just the amounts of stuff that's out there today.
It's huge.
It's pretty crazy to see. I think, Benson, you could probably talk to some use cases where that they're large that wouldn't have been possible without something like this, and maybe to you as well, Arlen.
Yeah, the scale is absolutely critical, especially as these systems start to expand. One of the problems we sometimes get into is we'll develop a POC, we'll come up with a quick way of getting the data out of, say, of an OT system up into some enterprise level software, or even level 3 software. It doesn't, or level 2 software. The problem is you can put yourself, you can pigeonhole yourself. And you always want to look at the architecture first. And those architectures, generally, the ones that are modern-based architectures that provide some degree of future proofing, is the use of edge, these publish subscribe models, getting the data out of those systems into enterprise applications, and doing it in a way that it makes it easy to scale.
Yeah.
So, getting back to that tier one automotive supplier, they started with one. And then once they got one done, they were able to roll out the other 100 and some odd machines in just a few weeks. That speaks to scale, and I think that's really important as you architect these systems. You want to be using the right technologies at the right moment.
And I can remember, Travis, when we started working with Inductive 10 years ago, a big SCADA system was 50,000 tags. We have customers using MQTT with 14, 18, 20 million tags. And so the amount of scaling that we've got, some of our largest customers, what they've been able to do with MQTT, even I look at, I go, gee, did they really do that? Are they really publishing that many tags? Because these systems are huge, and they have guaranteed us they are going to get bigger. We have customers now where they're asking us, hey, tell us what it looks like to scale to 100 million tags.
I know, yeah. The data's so important, right? And realize that we could start putting together architectures where we can get at more of that data.
Yep.
Right.
That's the beauty of, everything we're trying to do. Continue to scale, continue to architect systems that allow us to solve problems we never dreamed of 10 years ago. So this whole thing about the UNS, how does Sparkplug and MQTT deal with, the whole UNS type architecture? How does it all fit together from your perspective?
When I did the very first MQTT demo, I think the only people that knew about it was me and Travis. So I get up on the stage and I went through it. I kind of went through what MQTT was. And at the end of it, I pull up a live demo. I said, okay, I'm going to discover 300 PLCs and 150,000 tags, and I'm going to do it in 10 seconds. And I had these little vision screen, and it had little green dots, and it kind of went, boop, 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 done.
Our Sparkle chart.
At ICC, they passed around the microphone, and they passed it to this one gentleman. I'd never met him. And he takes the mic and he walks out in the aisle. I thought, and then he walks up on stage, and then he walks up in front of me, and he turns to the crowd and he says, "This is the future of SCADA." We were doing the UNS for Philips because we basically had created a hierarchical space with the MQTT. And Tom, the thing about MQTT, unlike any other protocol on the planet, is that you have a hierarchical, right with the topic namespace, you've got things already set up in a hierarchy. So really, we were already doing that, but Walker gave it a name. And he was good. He did a good job. He gave it a name. Hey, this looks like a unified namespace. And the thing we have to be careful of is that helps us organize our data so that as we all publish from different sources and different applications, we can go access that data. But ultimately, the MQTT broker is not the UNS, right? It's a platform. And that's where we talk about Ignition actually being the platform where your UNS lives.
Yeah, and I'll add to that because it's an important consideration as people are starting to roll these systems out. The beauty of MQTT and Sparkplug, if you architect your systems this way, is it does force you to think about how you're going to model your data. You're going to be publishing it on a namespace. You're going to be setting up, all of your data, whatever data elements you have from OT systems, from other applications or whatever. And as you do that, you're going to send that information to a broker, but you're essentially forced to model it right away.
Mm-hmm.
And I think that's an important step because you think about how you're going to distribute that data, how you're going to make it available to others in a meaningful way. From right out the gate.
Yep.
And that's, I think, is really important. It's a kind of a shift in how you're thinking about the data you have and who else may consume it and make sure they can understand it.
Because remember, here's the world we all come from. I've got 15 Modbus registers. Boom, they're here on the screen.
Right.
I mean, okay, well, what are we going to do with them, right? They don't self-describe themselves. They're flat. They don't have a hierarchy. So we kind of came right out of the gate because MQTT was a pub sub, basically an enterprise service bus for OTE. We got a namespace that came along with it for free.
Benson, you alluded to this earlier, but we got to talk about cybersecurity, right? Because, we're putting together these large architectures and we want to do that in a responsible way, right? And make sure security is kind of intrinsic from the very beginning of that. And that is very much what you talk about all the time. Give your perspective on the cybersecurity side and the importance of that with MQTT and Sparkplug.
Yeah, at the end of the day, you're still running software somewhere, right? And I would propose that you run it as close to the edge as possible. But once you do that, you're going to have to put it on some sort of platform. It needs to be secure. You need to limit access to those systems. You can't have some piece of software that's reaching out to a bunch of, say, PLCs or remote I/O and pulling all that data in, because that's a completely open attack surface to all those devices in the field. So as we're pushing this down, we're putting it into, say, an edge gateway, a Groove Epic, Groove Rio, whatever, but that device itself needs to be highly secure. And I don't mean by bolting on other cybersecurity elements to it. It's got to be innate into the system. And there I'm talking about, user accounts, no default usernames and passwords, connecting over a secure authenticated connection, firewall support. All of these things become really important because then you can clamp that thing down. Now, the other part that where Sparkplug B comes in again is all the data that we're moving out of that system goes on an outbound basis. So I'm sending the data to a broker to facilitate all the consumers who wish to subscribe to that data. And in doing so, I don't have any inbound open ports. If I got PLCs out there, most of them on the market don't have any security built in. So if I can get access to the network and I know that, the common protocols, 502 for Modbus, I can just go and ask it data because PLCs are servers. So this notion of a gateway and a secure device that's running this software is going to take that unsecured PLC data, translate it, model and contextualize it, and get it out safely. That's what I think is critically important. And let's be honest, all over the news we're hearing about this exploit and that vulnerability and so on and so forth. You've got to be able to protect these systems, not only from the IT level up, but on IT level down. Start at where the data originates. And so, yeah, to me, cybersecurity is absolutely critical at as close to the edge as possible.
Andy and I got lucky. Looking back in hindsight, we put MQTT right on top of TCP/IP. So people will read not the Sparkplug spec, they read the MQTT spec and go, Arlen, we can't use it. You guys don't have any security in MQTT at all. No, we don't. We let TCP/IP do all the heavy lifting for us. So the other arbitrary decision we made is that we were going to make remote connections to the broker. So, like you said, Benson, so think about it for people listening to this. Think about a classic SCADA system like Phillips 66. I got a SCADA host system. I had 400 outbound ports I'm connecting to out in the field, and every one of them, like Benson said, 400 of them just sitting there waiting to be connected to. Whereas when we were done with the project for Philips, there was no ports open out in the field, and there was one port open on the broker. And that's where you put all your protection from attack surface standpoint at that single point that you can protect.
I always believe in a standard is never done. It's going to continue to evolve because a good standard isn't completed because we have to continue to extend the standard for different things. So, Arlen, where are we right now with Sparkplug and the version and how do people get involved to help be part of, the Sparkplug working group?
It was a process. I mean, like I said, once CirrusLink had come up with the idea of Sparkplug, Wes, Chad, and we just put it on our own GitHub site, and we said, well, Chevron, Exxon, XTO said, well, Arlen, who owns the spec? And we go, well, it's in our public GitHub. I mean, what better can we do? And so they go, no, really, where are we going to get governance of this? So that's when we gave all the IP to the Eclipse Software Foundation. And if you're not familiar, Eclipse manages Java EE. They manage all the the new, like Java and Python IDEs, but they also manage specifications. So they helped us, and it took us 2 years to get the spec with all of the references and the addendums and all of the things that you put into an ASCII doc to make that into an official spec. Number one. Number two, we had to create a implementation that implemented all of the spec. So we started the Tahoe project in Eclipse. And so there's some Java code called Tahoe that implements everything that you can do with Sparkplug, from a remote client to a host client, whatever you want to test. And the third thing, we had to write the test software for customers to download and test their implementation of Sparkplug. Pass fail. Every assertion in the specification. So that is what we did originally. And that took quite a while. I mean, that was a 3 or 4 year project.
Hmm.
And now we're going to the next version. So we've had Sparkplug out in the wild now for about 6, 7 years. We've had a ton of feedback. And we've really pushed back until now so we can get as much of that feedback into the next release. It's going to be V4 of the Sparkplug spec. And I think most of the comments that we've heard, everybody's really happy with what we are doing. If you're interested, Tom, to your point, it's if you Google Eclipse Sparkplug Working Group, you'll find all of the resources there. We did a webinar last month that basically goes through all of the changes that will be going on into Sparkplug 4 if anybody's interested.
So Ben, I want to come back to you because you talked about how important the edge is, and we live in a world where there's still a lot of brownfield, there's a lot of greenfield, and we're putting these kind of solutions together to solve a lot of the problems. So what can you talk about how we could take advantage of all these pieces together and even potentially show us how we could bridge the gap and leveraging these kind of technologies?
Yes, indeed. As controls engineers, we would all love to work in a greenfield environment, right? To be able to architect something right from the get-go and exactly how we want it, using all modern tooling and so on. But the reality is, we live in a brownfield world. And in truth, we see a lot of greenfield applications, at least from an Opto 22 perspective, in a lot of OEMs, data centers. We have, big cooling units that are using our stuff with ignition for, liquid cooling of data centers. That's greenfield. But brownfield world is everywhere around us, and we have to be able to utilize these technologies to help, unleash that trapped data in these older brownfield systems. And indeed, we do just that. And that's largely accomplished by, again, this notion of an edge device, and in our case, running Ignition Edge, because Ignition has all these built-in drivers to communicate to all these brownfield devices. But also important is many of these brownfield devices, getting back to that cybersecurity topic, are not secure. So again, that edge device has to provide a method of segmenting those two networks. So on one network, I'm going to put my brownfield device, say, and I've got one right over my shoulder. I'll actually change my camera here, and you can see, I've got a brownfield device over here, which is my, Siemens and AB PLCs have no security, and those are going back here into an Epic, running Ignition Edge, and I'm able to use these drivers over a segmented network, pull the data from these brownfield devices, and then in turn model and contextualize that data and get it pushed up to infrastructure, an MQTT server, then it lands in Ignition and so on. And I'll actually show you some of this in practice. Now, this is a public demo, so for those of you listening on the audio podcast, this will probably not be super helpful, but we'll put links to all these demos into the podcast notes so you can actually go to these yourself. This one I'm showing on screen now is, again, just my browser, and I'm logged into an Ignition instance running on the cloud, put together by one of another technology, premier technology provider, 4IR Solutions. So you can see that there, and they've spun up this environment that we can publish data to. And then I'm using Cirrus Link tooling and also Ignition Edge down at the edge, where I'm actually communicating to brownfield devices. This is an old, a compressor that's at least, it's been here longer than I have. I'm connected to that guy, pulling data in, connecting to an air dryer. These are brownfield systems, but because I've connected to them and started to model and contextualize that data, I can send it all the way up to this cloud instance, all done securely. I can even send video files. So video JPEG images like this one you see here is a live shot of that of our facility where we make everything everything we make is made right here in this factory in Temecula, California, about an hour north of San Diego. So that's a live shot. And then I can dive in and start getting a lot more information. Looks like we just had a shift end out in the plant, so the compressors have wound down. But that's just one example of pulling data from brownfield systems. And then over on the greenfield side, for you audio listeners, I've switched to another demo. This is where we're running on our own AWS instance, Ignition Cloud Edition. So I have a portal open. I can see that I've got a QR code there. So if you want to take a snapshot and see this, is all mobile responsive. This is all perspective. But what I have on the side are all of these Groove Epic Learning Centers, very much like the one you see in my video there, and they're all over the world. I got one here in Germany. I've got another one here in Spain. And these are these learning centers with running a C-store application with device, all the information about what you might see in a C-store. So for example, I'll come to this one here. This one happens to be one that's in the video that you can see. And so here's the beauty of this. At the edge, I'm using Ignition Edge to pull all the control data for the C-store. I'm bundling that up into a UDT and I'm publishing it up to this broker or up to my MQTT server running on AWS. Then I'm using perspective templates that take that UDT data that was published up and automatically creates a template. So every store is exactly the same, just the data is different. So there's my HVAC in here. It looks like it's starting to cool back off in this room. Thank goodness, I'm a little hot in here. I can see the local weather, but I can switch to any one of these devices. Now, what's interesting about this particular C-store is right up here at the top is my PLC data. So even on that device, I'm connecting, and there's a red stack light connected to the AB PLC. And when I click on it here in a cloud application, what a lot of people don't realize is MQTT and Sparkplug B is bidirectional. So I can click that, and now I've just turned off the stack light, or I can turn it back on, and so on. So the idea here is, again, that I have full connectivity, all secure, everything is templatized. So as if another store comes online, it takes me, 10 minutes to bring it online, put it into this environment, and show people all the cool stuff it can do. So that's just a quick demonstration of some of this technology actually in action, all very performant, very secure, ideal for mission critical type applications. We got a lot of customers doing exactly what I just showed you there, including that aforementioned Genesee County case study where they did this across their 180 sites. Same exact ideas, but get to see it actually in practice.
And don't forget, we get to see it live at ICC with the Build-a-thon, because Opto 22 graciously builds our panels for the Build-a-thon, and we'll get to see like that C-store that we had on stage, as well as an exciting new one that we can't say anything about right now, Benson, but it's going to be awesome.
Top secret.
So Benson, again, thank you for doing a live demo. It was live, guys. This was not recorded. He actually did everything right there. He probably didn't even rehearse it because he can do it in his sleep. So I guess, what are the two of you guys most excited about moving forward? And what do you see is happening in our industry? And what can our audience do better using our technologies?
I'm excited about the future because there's, not only the advancements we're making with the various software, for example, Ignition 8.3, all the new tooling and capabilities for data ops and version control and so on. In other words, the software is continuing to improve and making our job much, much easier. And I'm also really excited about some of the, Arlen, I hate to do it to you, but I am going to call out AI. I'm a big Clauder, and I've been using Claude for, tying into these systems to do shell scripts, to develop applications. It's just an exciting time for us. And even though we're generally in the controls arena, deal a lot with instrumentation and PLCs and SCADA and so on. The challenge always is how much can we get done in a given day. And so some of these new exciting tools that are going to help accelerate that and allow us to do more than we've ever could dream of. There's still always a human involved. We have to make those decisions. We set the guardrails. But some of those tasks can be somewhat mundane. And so if we can take some of those tasks and automate them, I'm super excited about. I'm excited about what I've already accomplished in just the last few months using some of these tools to accelerate us doing more exciting things in the future.
No, from my standpoint, it's incredible to see what we've done. If you look at MQTT, we went from zero, literally zero. Nobody was talking about it in this industry 10 years ago. Nobody. To it's everywhere we look now. And I'm really excited where we're going to go with that, with the new V4 coming out. And, we get to see stuff, you can imagine, seriously, we have over 6,000 customers using Sparkplug now. And you can't imagine the, the crazy things they can put together, and they go, okay, look at this, and you look at that and go, wow, did they just do that? I mean, that's incredible. But yeah, the basically the end users that are taking Ignition and MQTT technology and just doing crazy things with it, I think it's gonna continue to grow. So I'm really excited about that and where that's going. And I think V4 is going to be it's going to be really that next level that we need, kind of a step change for adoption. So it won't just be, remote oil wells anymore.
I want to thank both of you for taking time out from your day. This is really very important of what you guys have shared, and your expertise with open standards and all the work you've done. And it really shows how we're pulling the whole industry together, into OT and IT, right? And solve real challenges and paving the foundation for the future. So we're going to publish some links at the end of our podcast here that basically gives people more information. It talks about everything that Benson and Arlen have shared with us today, some links to some of the case studies, and how to get involved with the Sparkplug activities.
Yeah, and for if you guys want to try out this technology, you could easily get your hands on it. You can go to inductiveautomation.com, go to the downloads area. You could download Ignition and all the MQTT modules that SiriusLink provides, and try it all out for yourself in a 2-hour trial period. Try it for free and see what this can do for you. And it's really exciting to kind of see the new use cases. But Benson, your hardware, how can people test out what you guys provide?
Yeah, it's pretty difficult to do a software download of hardware, but we're working on it. So, but to that end, yes, we do offer the Groove Epic Learning Center, which is a pre-built setup system similar to this one over my shoulder, and actually Arlen has one up over his shoulder. And it's all pre-packaged, ready to go. It includes Ignition. It even includes an Ignition Edge development license. So this is a quick way of folks getting started with this technology. We offer these learning centers through the Inductive Automation website. You can get information there under the Premier Technology Provider section, or on our own website. Just do a search for Learning Centers. We've got a special page that describes not only our Epic Learning Center, but also our Rio Learning Center. And one little piece of bonus, if you're working on a project and you're eager to get started with some of these technologies, see how they come together, and you have a project, we put together what we call our proof of concept request. It's just a form you fill out, and it helps our team work with you to understand what it is you're trying to accomplish, how we might get there, and then potentially offer some significant discounts on these learning centers so you can get started with very little risk. But remember, if you do get this learning center, you get an Ignition license with it. That's pretty exciting. Thank you, Travis, for making that happen. We have a lot of folks that are doing just this, and once they get started, boy, as Arlen said, they dream a dream. They dream it and do it, yep. And it all starts with Ignition.
Well, it definitely is a fun time to be an engineer again, and we thank you guys so much for for coming on and sharing all of your expertise. I mean, I know this is just the beginning, right? We're going to come back a year from now and who knows what's going to happen in this next year. It's pretty exciting to see. But as always, keep connected to this podcast. Subscribe to Ignited on YouTube, Spotify, and Apple Podcasts so you never miss an episode. We thank you all for joining us here today, and we'll see you next time.